All right, we have the new chapter, rational expressions. So rational means fraction form, okay? So we are going to have something on the top and something on the bottom, all right? Therefore, it's going to cause some issues, right? Later on, but nothing too much. So we're going to look at, so they show you some examples of some rational expressions here. We're not going to have just numbers. We're going to have binomials and trinomials and things that need to factor. All right. So for example, 1 over x, m over m plus 1, a monomial over a binomial. We have a difference of squares, I think, on top over a trinomial on the bottom. That sort of thing. So we do have one complication when it comes to fraction form. And that is our denominator, right? So for example, let's say that I have x minus 7 over an x minus 3. I have two binomials, right? And they tell me that x is equal to a 3, all right? So if I substitute a 3 in, I'll get a 3 minus 7 on the top, giving me a negative 4. But on the bottom, I end up with a 0. What happens when I take a number and divide it by 0? Try it in your calculator. Take this negative 4 and divide it by 0.
I gotta get my calculator.
Stacey's got a calculator in front of her. You got an undefined. You get an error. Right? It's meaning you're taking negative 4 things. Even if it was positive, it's probably easier to think of it as positive. You have 4 cookies, and you're dividing it into 0 groups. Can you do that?
So it equals 4.
No. You cannot divide something by a 0. All right? It's undefined. All right? So undefined in this meaning there is no answer at when x is equal to 3. I do get an answer if x is anything but 3. Right? I can put 4 in there. 4 minus 7 gives me a negative 3. And 4 minus 3 gives me a 1. All right? I would get a negative 3. My answer would be negative 3. So we're going to have a chapter here that's coming up where we're going to graph what these things look like. And when we graph a rational expression, they actually are consisting of different kinds of curves. But there are dead spots in the curves. All right? And those are called asymptotes. Asymptotes create these spots where the graph doesn't actually exist. So let me see if I can graph this one real quick and so you can see what it looks like. So I'm going to just clear up my calculator here. And so on the top, clear, I get an x minus 7 divided by an x minus 3. All right, I'm going to go zoom 6 and see if I can get this. So this is the graph of what that looks like. Now, it appears as a line in the center there. That line, I'm going to go to the table now, and I'm going to show you. So when I said x is equal to 4, that means that if I go down the x column and I get 4, there's my negative 3. Okay, so if I hit my graph button, if I go over to 4, my graph is going to be down. There's 4. My graph's going to be down at negative 3. Right there, which is agreeable, right? But let me go back to my table. When I put 3 in, what happened? I get an error. And in my calculator, because it's the older style calculator, I end up with a line. This line right here actually doesn't exist. The graph really looks like this. Here's my x and y axis. It goes like this. It runs along the x-axis here, and then it goes up like that. And it continues on forever. And then a part of the graph goes this way and then down. And right at x equals 3, nothing exists. It runs infinitely along 3, but it will never, ever, ever touch 3. So if I go to, let me go back to my table, right? You will notice that as I get larger and larger and larger, oh, no, I don't want to go that direction. I want to go this direction. No. Oh, come on. go this way. Right above there. See where 2 is? 2 is actually a 5 up here. And if I chose a number that was really, let's say close, let's go to table set, and I'm going to go decimal. I'm going to go 2, but I want to go by 0.1s. I'm going to end up with, see how my graph gets 2, 2.1. My graph gets really big. It gets really big, and then as soon as it hits 3, it's an error. Because this graph does not exist at 3. So when we do these questions, we're not going to be graphing them in this chapter, but we do have to be aware that there are certain answers that are going to give me undefined answers. All right? And I have to state those undefined answers. All right? Those undefined answers are called non-permissible values or restrictions. Okay? What do they use in here? They use non-permissible values. They're values that we have to be aware of. Where does this thing create that error? Where do these, I hate my graph. Where do these lines appear? Okay? And just like anything that has an X in it, we're going to have one spot that's going to create an error. When I have a binomial, how many do you think are there going to be? There's going to be 2 of them. So let's just say that I popped this guy in. I'm going to change this one to be an x squared minus 9. Look at this thing. It's got 2. Somebody have a brand new graphing calculator, like the really new ones? Yeah, let me try that one. I wonder if it gives you the asymptotes. Or does it actually just show you... Yeah, whether it just shows you... Yeah, I know. There's always clear. There's always some lovely words in math. When we used to teach different figures, in a semicircle, like in a semicircle, or not a semicircle, an oval, the distance between the 2 radiuses on them was called the latus rectum. I'm not sure even why they called it that, but it was just, I'm like, oh. All right, so let me see if this one gives you the x minus 7 divided by x squared minus 9, 6. There we go. So if you have a new graphing calculator, it does not give the lines. But, yeah, that's pretty cool, hey? When you do, look at the errors. There they are. -3 and +3. Now, if my graph is, now look at this denominator. This is a super one. Why does 3 and -3 end up as errors? Look at your denominator. It's an x squared minus 9.
Oh, wow.
Right? Because where do I not want this thing to be? I want it not equal to 0. I want it to know, so I'm going to move it over here. X squared minus 9 cannot equal to 0, right? I don't want it to be equal to 0 because if it equals to 0, then I will get those errors, right? So I need to know where those errors are. So you can do it one of 2 ways. So Aaron was thinking, okay, if I go and put my 9 on the other side, how do I get x by itself? Square root it. This means not equal to. Cannot be equal to. I do not want it to be equal to 0. So where do they show up? At 3 and -3.
Wow.
So that comes from, see how this one right here, x is x minus 3. X minus 3 cannot equal 0.
But that's just
X cannot be equal to 3.
It's only like it's a perfect square, right?
All of these are going to be factorable.
Okay.
right? So if you look at, let's look at this way, right here, right? Where would this guy be undefined? What do I have in the bottom? I have a trinomial, right? If I knew what the factors were, I'd be able to solve for it. So let's do that. Let me take the x squared minus the 4x plus the 3, right? I'm going to set it not equal to 0 because I don't want to know, I want to know where exactly I'm going to get those lines. Where is this graph undefined, all right? How do I factor this thing?
You don't.
Oh, yes, I do.
Wow.
Ah, it's a trinomial.
Is that like a... Yeah.
Right, x minus 3, x minus 1, right? Cannot equal to 0. X minus 3 cannot equal 0. X minus 1 cannot equal 0. So x cannot equal a 3, and x cannot equal a 1.
That's hilarious.
So I'm going to pop it into Aaron's calculator here.
I guess I should...
And I bet you anything, that is where our asymptotes are going to show up.
So if we just ignore the top one, then-
At the moment, when I'm looking for where it is undefined, I always ignore the top. Because, there it is. See, I'll move it in a second. There it is. 1 and 3. They are right there, and they're right over here. And if you go into the table, you'll notice at 1, there's an error, and at 3, there's an error. 1 and 3. So the numerator, can I have a 0 in the numerator? Can I take a 0 and divide it by a number?
Yeah.
I have 0 things and I divide it by 7.
Man,
Yes.
you
I
got...
still have 0 things. It doesn't matter how many times I divide it by 7. I'll still have 0, right?
It's on air?
It's not an error.
Yeah.
If I have nothing, essentially I can divide it however many times I want to divide nothing. I got nothing. I can give you guys, it's not nothing, right? I can divide it 10 ways.
Quite easily,
How much do you have now?
actually.
You got nothing because I've got nothing, right? But, so the numerator is going to come into play later on. At the moment, what I'm concerned about is where do these things come from? Where do these appear? And so in this chapter, they're having you do the math behind the questions so that when we get to that next chapter and we are going to graph these things by hand, right? You know exactly where those asymptotes are without even a graphing calculator. Because remember, life isn't always you don't always have a graphing calculator on you, right? You don't always have a math class where you'll be able to use a graphing calculator. Saskatchewan high schools, we get to use a graphing calculator because they're recommended. But university, if you take a class at university, sometimes these aren't allowed. And you never know when you need to solve a rational expression. You know?
Yeah, is there anything
Yeah.
in your life?
Happens every day.
Oh, it happens all the time. My life is just one giant rational expression.
That's how you should, like...
Right?
That should be like a phone password.
So let's look at a couple more examples here.
Equation like that, math equation.
I do math just for fun, you know that. So they're called non-permissible values. So we're going to just determine, today, that's one of the things that we're going to do today is just determine what those values are. All right? Now, let's look at my denominator here. So the non-permissible values are always in the denominator. I can ignore my numerator for the moment. When I get to reducing and adding, subtracting, multiplying, dividing, the numerator comes into play. But the denominator is what I'm worried about right now. So what values of S and values of R would I not want them to be so that they end up at 0? So when I have something like this that is essentially, it's a monomial, right? So if I think about it, not equal to 0. If I want to solve, let's say I want to solve for S first. Let's do S first. 4SR squared cannot equal to 0. And that's what you're going to, your thing you're going to do is you're going to take your denominator, set it not equal to 0. right? We did that with setting them equal to 0 when we wanted to find our x-intercepts before. Now we want to find those spots where it shouldn't be, right? So I'm going to keep s, and I'm going to get rid of everything else. So I'm going to divide by the 4 and the r squared. And what I do to one side, I got to do to the other side. And I get s is not equal to a 0 divided by a 4r squared. Well, what's 0 divided by anything? 0. So s cannot be equal to 0. Because 0 divided by anything is just 0. Is that going to be the same answer for my r? Yeah. But we'll prove it mathematically. Need to get a better eraser. SR squared cannot equal to 0. I'm going to divide by the 4s. R squared is not equal to 0 divided by anything is still 0. And the square root of 0 is 0. So when you have monomials like this, essentially the only number that you could possibly put in for s or r is 0 to make it 0. There's nothing else you can do to it. But when you have binomials, the reason why there's another number is because you're adding or subtracting to that 0, right? Or you're adding and subtracting to that number. Whereas 0 was not one of the answers here because 0 minus 3 gives me negative 3. So that's why 0 didn't show up. 3 did, right? 3 minus 3 is the only thing that's going to give me a 0. All right, let's try the next one. So, and then we write, so our final answer we would write s cannot equal 0 and r cannot equal 0. And we would write it off to the end. It's kind of like there's going to be an answer. We're going to be doing things with them, like we're going to be reducing them like fractions. We can reduce fractions, and we can add and subtract and multiply and divide. We're going to get an answer, and then we always state our non-permissible values after. It's kind of like a little, here's my answer, but that's only my answer because these are not 0.
So there's no brackets?
No, there's no brackets or anything like that. All right, so let's see what this one is. I think it's already factored, isn't it? All right, we got a monomial and a binomial. So I'm going to take them. So this guy, x cannot equal 0. There's my first guy. A 0 for my x value. So there will be an asymptote at 0. And the other one is going to be a 2x minus 3 not equal to 0. 2x cannot equal a 3. So therefore it cannot equal a 3 over 2, which is essentially 1.5, right? I'm going to leave it as a fraction, but just be aware. So if I graph this one, there would be an asymptote at 0, and there would be an asymptote at 1.5. There would be errors. So I'm going to have some kind of, so I'm going to write my answer. All right. X cannot equal 0, and I can go to 3 over 2. I can write it like this time as a list because I'm using the same variable. Whereas this one I had to write it as 2 separate things. But I can do that. All right, let's look at the bottom. Again, I got a p squared minus p minus 12. I got a degree of 2, so that means I could possibly have up to 2 non-permissible values, right? 2 spots where those asymptotes are going to be. All right, let's take our denominator. So you always take your denominator. Set it not equal to 0. Factor. And then solve for x. That's your steps, right? P squared minus a p minus a 12 cannot equal to 0. Go ahead and factor. Oh, you should have seen my 9s and 10s today. They were like little algebra geniuses.
Good for
So
them.
good. They get to learn FOIL on Thursday.
Oh, I feel so bad for them.
You don't feel bad for them, obviously.
They're gonna love it. Unfortunately, the 10s, because of COVID, they didn't get algebra last year, so they have to learn algebra this year and factory.
Wow. Pretty easy stuff, though.
I know. But usually I don't teach it both in the same year, right?
Actually, I can't really do
Yes, you can.
that.
You do it every day. Did we get a P minus 4 and a P plus 3 not equal to 0? How many did decomposition when they didn't need to? Come on.
I didn't even do that this time.
I
Yay.
just didn't do it.
What?
Sorry.
I gave you enough time.
Yeah, well, I was talking to you.
Oh. You can't do math and talk at the same time?
Come on, you.
Alright, P cannot equal to 4 and P does not equal negative 3. If you can go directly from this step to this step, that's fine.
That's what I did.
Yeah. You just wear, all it does is change the sign, right? If it's a negative 4 in the bracket, it'll be a positive 4 outside the bracket. And then P cannot be equal to a 4 and a negative 3. And again, it doesn't really matter what order you put them in.
This is boring.
What?
Boring because it's easy to accept it.
It's not bad.
This is good.
All right.
I'm a fan.
All right, so let's move to the next step. So I said that we had to do something with these rational expressions. So think about when you get back to when you're in a fraction chapter, right? The first thing I teach you in fractions is how to reduce a fraction, right? I show you how to take, let's say I have 36 over 45, right? And 36 doesn't go into 45. So this is the way I teach it now, is I teach it by using factors. I break it down. I know that 45 is 9 times 5. I know that 36 is 9 times 4. I cancel out the factor that's the same, and then I write my simplified answer.
That was not a thing back in my
Well, it's a new method I've started in the last couple of years. It works perfectly. I kind of fine-tuned it. I like it much better. Kids don't get the idea of dividing by 9. They're like, where does the 9 go? I'm like, it doesn't go anywhere. It's a common factor. Yeah, but where did you get it from? So I stopped using that, divide by 9 thing. So I got rid of that. They see it much better when you do factors. All right? We can do this with these. All right? Now, I factored these. That essentially is factoring a number. Right? I broke it down to 9 times 5 and 9 times 4, and I recognized that there was a common 9, and I could simplify it and reduce it down to that. So that is the same thing as what they're going to be asking you to do here. Okay? I'm going to come back to this after. Aaron, how would we do this back?
You sell it.
No.
So
I like your...
That's easy to get
that was
rid of.
Yeah.
Only
All right.
$5.
So this is where the front cover comes from. If you do this, the kittens will die.
Whoa.
Have you not looked at the front cover?
Well, that-
Yeah, look at the front cover.
Not recently,
well, I don't really care about this.
So,
honestly. There is a puppy.
puppy then.
Wow,
puppy.
that's
So, this is the case where I have a rational expression, right? I have a trinomial on the top, and I have a binomial on the bottom, and what they did was just canceled.
That makes sense.
That's like doing this. Let's say that I had a 15 over a 25, and I just do this.
Yeah.
Yeah.
Think smarter.
There's just a 5 there, and there's another 5 in the other one, so I'm just going to cancel them with 1/2. Is 15 over 25 1/2? No. There's no way. It's never going to happen. This is canceling, then factor. And heaven forbid, That's the wrong thing to do. You can't do that.
That's
All right?
hilarious.
So this cannot be done, and neither can this. They didn't factor it. They just took the trinomials and went, well, they have a common x squared. I'm just going to cancel out the x squares and just write the answer.
That's what I would do.
Right?
Like, because they know
It just looked like it should work, but it doesn't.
Because there's a plus, it's not like.
I know. You can't. So that's like, I cannot just take, a 3x and an x, cancel them out and get a 2x. I can't do that. Because remember, they're binomials. It's a trinomial. They're an entity of itself. I used to call it like little families. Like this is a 2-person family and this is a 3-person family. I just can't take, the sister out of this family and bump off the sister in this
They do it
family
all
and
the
just
time.
get rid of it.
They do it all
Right?
the time.
I have to factor first.
Generally, people have-
Right? You can't do it. So nobody would reduce a fraction like that. So you can't reduce a rational expression like that. So you must factor it. It says, simplify the rational expression and then state the non-permissible values. So just like I had in this question over here, we're going to do this part right here, this answer part. That's the simplifying part. And then we're going to state what the x's could not be, or what my denominator cannot be. So let's do the factoring part first. Let's do part 1 first, and then we'll do part 2. So part 1 is simplifying each rational expression. All right, let's look at the top. 3x minus 6. Let's factor that. Pull out a 3. Thank you. Somebody is paying attention to me. And I'm left with an x minus 2. So far, so good? Bottom. What kind of factoring do I have there? Ooh, it's Tanner's favorite. Decomposition. Oh, I know it's your favorite. 2x squared plus x minus 10.
Just times the 2 and then.
Times it to those two. So I got a negative 20 and adds to a
X.
1.
Negative.
20, but
5
adds to
and
1.
4.
5 and 4. And which one has to be positive?
5.
5. So I'm going to do that. Just because I want to. I'm going to put the 2's with the 4's and the 5's with the 10's. And I'm going to factor x minus 2. And I need an x minus 2 there. Oh, I got to pull out plus 5. You should be good at these by now.
What?
You've been doing them for like 3 years. And that's going to go on the bottom.
Did you say every summer at recess?
It resets.
Oh.
Oh, no. Okay, sorry. Oh, I thought maybe you had done it yourself.
Yeah, like I am.
I'm just checking my work.
All right.
Wait. Wait.
Now, when I do this, think of number 2, the non-permissible values. Have I already done the first step for the non-permissible values?
Yeah.
Yeah, I've already factored it. So before I start doing anything else, I'm going to get these guys. All right, I'm going to find what x cannot be equal to. So I'm going to look at them. What is this guy going to come out to be?
5 over 2.
Positive or negative?
Oh, negative.
Negative 5 over 2. And what's this guy going to come out to be? Oh, come on. 2. Okay? So that's what I did. I factored my top, factored my bottom, found my non-permissible values. Now the last thing is to do this, is to cancel out and get that lower version. Are these the exact same answer? If I drew out that picture, would they look exactly the same? Yeah. That's what I'm doing here. Do I have anything common, top and bottom, that I can reduce this fraction by?
You can take away both.
Minus 2.
I can take out those 2 binomials. No, they're binomials.
Yeah.
They're identical,
okay.
right?
Yeah.
So binomials I can cancel out. Binomials I can cancel out. Trinomials I can cancel out. Monomials I can cancel out. But I can't cancel a monomial with a binomial. Or a trinomial with a binomial. No, that's okay. So now this final answer in its reduced form is that.
Okay.
Where x cannot be equal to a negative 5 over 2 or a 2. There is my final answer. So there's my answer. That's what the lowest possible form of that question can be. At the same time, that is my non-permissible. Now, you're probably asking yourself, and you may not have even thought of this, but some of you may have, well, is the 2 still a non-permissible value?
I definitely didn't do
That was exactly what I was thinking actually.
Because I canceled it out, right?
Wow.
But the fact is it existed, right? It existed originally. It's the same thing as here, 4/5. I'm telling you the answer was 4/5. Could the question have been 36 over 45?
Yeah.
Yes. Right? It could have been. Could it have been something else?
Yeah.
Yeah. But when I write my restriction and say, this is my restrictions, is there any possibility that you could guess what the original question is just by telling you, this is my restriction?
No.
Yes, it could, right?
I would
Because
test
I could, because they're going to ask you that in the assignment, right?
it.
If this is my answer and these are my restrictions, what was the original question? This one right here gives me this factor, right? But in order for me to get this guy, what would that factor have had to have been? It would have had to have been an x minus 2, right? I'm gonna move it back. Right? And if I had canceled it out, how many should there have been of them? 1 on the bottom, 1 on the top.
So what you getting at
It means that my restrictions can tell me what my original question would have looked like.
here? No.
Yes!
Are we gonna have to
Wait, what are we
go
talking
backwards?
Yeah, there's a couple questions.
Oh.
Could you go backwards?
Oh.
Right? There's no way of going backwards with these questions, right?
I mean,
But on this one, I can go backwards because of the fact that by telling you that the denominator cannot be a negative 5 over 2, which is definitely that one right there, but the denominator cannot also be a 2. So that meant that the original question had to have had one of these on top and bottom.
Oh.
So what situation would you ever need to have that?
Right now,
wow.
I don't know,
This is
Stacey.
a very special moment.
It's one of those moments
I think we should
where
celebrate
it's
this
just,
moment.
you know, it's like, it's just cool to know it.
I almost felt seen there. We're going right there.
What?
It's a lot.
All right, let's look at
Your
another
voice
one.
is really, very sweet.
Oh, I like this stuff. This was fun.
Ooh.
All right,
I see.
let's factor this thing.
You hit me.
Hey, Dominic, what do you got going on?
You want to do some factory again?
Are we doing some work?
Morning, sunshine.
Can I factor my top? Ma, let's pay attention. I know this is a long process, but
No?
by now you should know. No, good.
That was a nice thrill, wasn't it?
Taylor's with me here.
Wait, we're gonna cancel out the ones you said.
No, we're not going to kill off the kittens.
Oh. But I wanted to.
No.
Just
All right, I factored the top. It didn't do anything. T squared minus 1. Come on, Tanner. It's an easy one.
One.
T squared minus 1.
One.
So, isn't it positive and negative 1?
Negative one.
Isn't it positive and negative 1?
Wait, you're asking me a question?
Yeah, I want you to factor it for me.
Please tell me I'm right. I want to be right for once.
Oh.
Yes!
Yay! All right, so
Yeah, I still don't
now,
know how that works.
so what do you, all I did was factor the top and factor the bottom.
Oh.
Gee.
Wait.
Now we can cancel it.
No, before I cancel out, what do I have to do
Look at
first?
those ones
Find
and
your
twos.
non-permissible
I gotta find my
values.
non-permissible values, right?
Alright. 'cause they-
One and one. One and negative one.
Yeah,
Right.
one and negative 1.
T can't be equal to 1 and negative 1.
Then we're done the question or what?
No. Now I get to
Yeah.
cancel something out.
Ah,
Now, they have to be identical for me to cancel them out.
They
So,
look identical.
T and minus 1.
Well, this guy definitely is not because he's got a minus in it, and this guy doesn't.
Oh.
But,
That one.
are these guys identical?
Yeah.
There's
Yeah,
no
just
filter.
because
No.
of that.
There's a negative T and then the positive.
All right, I have a negative T and a positive T. I have a positive 1 and a negative 1.
Oh my gosh.
They're opposites of each other.
Opposites attract.
In this case, they do, but they also leave something behind. So think about this. Yes, they do leave a baby, and the baby is a -1.
Whoa.
And the reason for that is this.
That's a
Look at this.
negative baby.
1 minus t, I'm going to take the top. And I'm going to pull out a -1. What happens to my 1? It becomes a
Negative.
-1. What happens to my negative t?
Positive.
Is that what I need?
Yeah.
Yeah. So when we have complete opposites, I can go like this, whoop, and then just go -1. It reduces down to a -1. When I cancel these two out because they're identical, what really is left? A 1, right? When you cancel out opposites, you get a -1. So this question comes out to be a -1 and a t plus 1. There's my answer. And then I'm going to write my non-permissible values behind it. So again, if I gave you just the answer, right, and I told you t plus 1, that's this guy right there, right? You would know that there was another factor that was t minus 1. That could have been. All right, what else we got here? We getting the point? I do have extras, more. Do you want to do some more? Let's go to one of those. Let me go into the assignment and see if I can find one of
Still don't
them.
understand
I think you should
that.
play Jeopardy or
Yeah.
something.
No, let's go to this one.
Or Battleship. That was good.
Oh,
Battleships? What?
Counters like bad words.
all right. Let's go to B.
My ears down.
We'll get you geared up for this. Sometimes thinking backwards is the hard stuff.
Yeah.
It tells me that this is my answer. The second one is your question. So these two are equal to each other. So one of them is the answer, one is...
A18.
And they're telling you if this part right here, x cannot be equal to 0. But my final answer, when reduced, goes down to a 5x. They're asking you what that numerator could have possibly had to have been in order that I reduce it down to just a 2/5. So my best way of doing this is to do that factoring thing that I did with the 9 times the 5 and the 9 times the thing. Take this one and think about, all right, 35 is a 7 times a 5 times an x. That's what that is.
What the heck?
I need it to just be a 5 and a 2.
I'm so sick of this.
What was the top? Well, the top has to have a 2 over here because it stays on the other side.
And it's 7.
And a 7. They would have canceled out. Anything else that needs to cancel out? The x. Because these had to cancel out in order for me to get no x's. The 7s had to cancel out for me to get the 2. And therefore, the original question, that numerator, had to have been a 14x.
Well, that's easy, Shmee.
That's what that numerator had to have been.
Actually, 14?
So my original denominator was, I factored it out, 7 times 5 times x. And I'm left with a 2/5 at the end. Means I can only keep that. And I had to keep the 2, so there had to have been a 2 up on top. So what else, what do I need to do in order to get rid of this 7 and this x? It means that there had to have been a 7 and an x on the top for me to cancel them out with.
Can I just do 35 divided by 7?
Times
7 times 2 is
Yeah, you can see the patterns after you're done, right? They work with binomials or with monomials only. Let's look at this guy, D. Look at D.
That's
Done.
I need to have this guy
7.
only become that. So again, factor it. What was this original thing? How do I get that x plus 2 out of this thing?
well, take it a 2. 4.
Take it a 4. I don't know what this bottom is. but I need to end up with an x plus 2 and an x minus 3. And x cannot be equal to 3. So I want to keep this guy. Do I want to keep the 4? Is my final answer have a 4 in it?
So there has to be 4.
There has to be a 4 on the bottom.
And you leave
X
the-
minus 3.
Yeah, and there has to be also an x minus 3. Because I need it to have an x minus 3 so it keeps with that x minus 3. The 4s would have canceled out. The x minus 3 would have been there. And that would also give me that fact that my restriction is x cannot be equal to 3. So there's what my denominator originally was. And I could write it like that, or 4x minus 12. Either. I don't really care. This is actually, in fact, probably harder to do than it is. You got to really understand what is it that I have and what do I need.
We should do C. I like C.
Oh, C, I think C you can do C.
Yeah.
It's 11.
But can I answer it?
7.
Yeah.
What else do we have here?
It's 7.
Oh, 2 is very similar to it. Here's the state the operation and the quantity that must be applied to both numerator and denominator of the first expression to obtain the second. So they want to know, oh, I know, it's a huge explanation. Essentially what they want to know is, what did they do to this one to get that? Or what did they do to this one to get
We
that?
took out a Q on the
So what would you have to do?
to the denominator.
Squared.
Yeah,
On the
you would have
bottom.
to have another P, right? You have had to multiply by another P. What else?
13.
And a Q. Nope, I don't need a comma. We need a Q. P and a Q. And what I do to the bottom, I got to do to the top. So I multiplied by a PQ. I multiplied
PQ.
by a PQ. And all they're doing here is getting you to think about what factors do these, rational expressions look like? What are they made up of? How do I get from one form to the next? Okay, so that's what they're going to ask you there. So a little brain thinking there. This one only asks you for what values of the variable, if any, make the denominator equal to 0. They're just asking you for the non-permissible. They're not asking you to reduce them. They're just asking you to do that, just to give me these. Okay? And same thing for this. So this whole page, they're just asking you to give me the non-permissible values. There's no simplifying involved. There's no part of that answer part. Okay? Then I think once they get you to page 7, I know these 7. Sorry, I went a little crazy. I had 2 different textbooks I couldn't choose from, so I just put them together.
We should only do vowels.
So yeah, you should be good there.
We should only do vowels.
Oh, I don't think so. And then they give you these ones. They just want you to simplify once you get it. Don't have to write the non-permissible values because that does take a little extra time. So these ones are just simplifying. Just straight factoring and canceling, factoring and canceling.
Even those we should just do vowels.
Oh no. Oh, you'll be fine. You'll be okay.
Give it.
Oh, where's that one that? Oh,
I need to do something else.
oh. Let's see who remembers how to factor the sums and differences of cubes.
I would just take it over the next.
I'll write the formula up there.
Yeah, you just take it from
Remember the a plus b, a squared minus ab plus b squared?
Wait, what?
In the special factoring chapter,
What grade was that?
like a month and 2 ago.
Yeah.
And then there's lots of those. One of those, why can't you do that kind of questions. And then there's a couple word problems.
Take a break, a little walk.
You can take like a couple minute break and then dive right in.
See, I think that if you just were the one writing it down and said, okay, well, you have to do this. I always did all